which can be then boiled down to logical expressions and can be used them. You can build them using gates. Okay, so this is the algorithm we'll follow. Define the problem. Second, write quasi-logic statements. Then we'll write Boolean expressions. Simplify to use minimum number of gates. Okay, so that's the same thing which we saw earlier. By use too many ICs, just reduce it to simple possible case. And then finally draw circuit diagram and or truth table. Okay, so here is a sort of a made up problem. Okay, so that's one thing that the student will use. The other, or the student will attend class if there is an exam and if the student got at least 6 hours of sleep. Okay, so the question is develop a Boolean expression for the student's heuristic. This is where the logic is. And that's the question. So let's see if we can figure this out. Okay, so what I'm going to do is, for something like this, I will use these 5 steps. Okay, so define the problem in words. So here what I'm going to try to do is I'm trying to identify how exactly, what exactly are going to be my inputs. Step 1. So the output is clearly attend class or not. Yes, that's why. So it's only 2 outcomes, 0s and 1s. Let's choose A to be the input, whether this is, if A equals 1, it's a Tuesday. If A equals 0, it's not a Tuesday. And I chose this because one of the condition was the student will attend if it's a Tuesday. Let's choose B as another input. And for this one, we know that the student will attend if it's an exam. So B equals 1 if there's an exam. B equals 0 no exam. Okay, there was another condition which said that if the student got at least 6 hours sleep, then the student will attend, which means that this should also be one of our inputs. C equals 1, greater than 6 hours sleep. C equals 0, less than 6 hours. So you can notice that everything which was given in the problem was reduced to zeros and ones. Okay, now every time that may not be possible, as you'll see in the next example, but in this case, everything is zeros and ones. So that's our problem. Next step is we need to write a logical expression. So the expression is attend class, that is y equals 1. If, what are the conditions? There are 2 conditions given. I'll highlight them. Attend class on Tuesdays, and if the student got at least 6 hours sleep. So, and is the key thing here. Attend class if there is an exam, and if the student got at least 6 hours of sleep. So there's an and then you can see that there's also an or. So it looks like there are 2 conditions. This is one condition, which is put in green. And there's the other condition, which is in blue. So we just try to write that now in terms of A, B, and C. So we know that so this is A. 6 hours sleep, I think it was C. This is C. Exam is B, and 6 hours sleep is C. So let me write that down. So as you know, in terms of inputs. So attend class if is Tuesday, which means that A equals 1. And then remember there was a and, so we need to write and if greater than 6 hours. So that would be RC. So C equals 1. And then remember that this was tied up with or if there is an exam, which is basically B equals 1. And then and if greater than 6 hours. Okay, so let's see how to, given this information, it's coming from our this expression, the final expression which you're after. So we want y equals 1 if I would write the first term, for the first part, this part as an expression. It's going to be A dot C. And then the second part is B dot C, and the dot is coming because of this ands. And then we see that there is an or here, which should be plus. Okay, so we have y equals A plus B dot with C. Okay, so then we've done step 3. Then step 4 is to simplify to use minimum number of gates. Now this is kind of interesting. Here we see that this expression is actually pretty simple, but it still needs quite a bit of gates. So if you if you write it this way, you see that you need 1 or 2 and. If you write it this way, you need 1 or 2 and, right? Either case, you need two chips. And why you need 2 chips is because OR gate is on 1 chip, AND gate is on another chip. There are 4 AND gates, so you could just one. Okay, so maybe that's good, maybe that's bad. Now I'll show you a way in which you can actually simplify so that you don't really need to have 2 chips. You can only do it with 1 chip. And the trick here is to actually try to write it as using NAND and NOR. So what we'll do is we'll use the De Morgan's law to do that. So 5, minimize gates. So we have A.C plus, so y equals A plus B dot C equals A.C plus B dot C. Now what we know is from De Morgan's law, we have A plus B bar is A bar dot B bar, right? Or you can write A plus B equals, I can take the inversion of A plus B. So there's 1, so I invert it again, so I put another bar, which means that I need to take a bar on both sides. So I just took the complement of whatever was there, and that was down to A plus B equals. So we can use this to write, so this is my A, this is my B. We have A dot C bar plus, sorry, dot C. It's maybe hard to see. We just write it in a using different use some other letter that makes it easier to do it this way. P plus Q, P dot Q dot. So P plus Q. So P plus Q is P dot. Okay, so this is P, this is Q, and maybe now it's more obvious. This is P. Okay, so how is this simple? I'll stop here, but I'll continue next class. You can think about this. Why is this simple? It turns out that this requires 3 NAND gates. Where are the 3 NAND gates? It's here. That's 1. Here's the second one. And here, this one is the third one between these 2 places. So you just need 3 NAND gates, which is 1 chip, 1 IC. Okay, so that's because 1 IC NAND gate has 4 NAND gates. So I'll further solve it next class. So I'll see you. Next class is exam ethics. So I'll see you on Tuesday. Then I'll finish it on Thursday. Okay. So here's another problem. Okay, again a hypothetical problem. Okay, an investor in a mechatronics startup uses the following heuristics to invest in potential new companies. Okay. The startup is rated for its mechanical design content. Okay. with he or she rates it as 0 or 1. So 0, let's say, is bad, 1 is good. The startup is rated for its business potential. It can generate revenue or not. Again, there's a two ratings, either good or bad, 0s or 1. The sales pitched by the founders of the company, and this is rated on a scale of 0 to 3, with 0 being poor and 3 being excellent. Okay, so that's how those are the metrics. Think of that like a questionnaire which the investor fills up. Now, once he has filled it up, he needs to make a decision whether he or she will invest in the company or not. So the investor would do the following. We need to probably underline this. Okay, so the investor invests in the startup if the mechanical design content is good and the sales pitch is rated 3, or if the mechanical design content is good or the business potential is good and the sales pitch is rated either 2 or 3. What I can do here is I'll actually try to separate things up a little bit. So there's an or here. It looks like this are 3 conditions which need to be met: mechanical design, or the business potential, and the sales pitch. Okay, and then we have is an and, or, and so these are like the keywords or and, which will help us to figure the solution to this. So let's dive into the process. We will follow this recipe. Okay, define the problem, write quasi-logic statements, Boolean expression, and then we'll simplify. And then the last one is optional. We've not done it for the previous one. Let's just draw the circuit diagram. Okay, so here's the steps. Define the problem in words. Okay, so in order to do that, we need to define variables, right? Like A, B, C. So let's go ahead and do that. Let's call Y as our output. Okay, this is okay, so equal to 0, not investing, equal to 1, the investor will invest. Now let's define, looks like there are 3 conditions, 1, 2, and 3. So we need to define variables because those are inputs to the decision-making process. So let's see those and try to put them, quantify them into variables. So let's say A is the mechanical design content. And that can only have 2 ratings, 0 or 1. So 0 equals, let's say, bad. 1 equals good. Then we have business potential. That's again good or bad. So let's call that B. Zero is bad. 1 is good. Last one, C, is the sales pitch. And now we have actually something more complicated than what we've seen so far. It's no longer yes and no, but it is a rating from 0 all the way to 3. So 0, 1, 2, and 3, just like you would rate something on, I don't know, Google, right? For restaurant you go to. So let's call that C. Now, if we use C and C is a Boolean expression, then we have a problem because C can only be 0 and 1, but we want to represent 3 levels, 4 levels, 0, 1, 2, and 3. So we need 4 levels. In order to represent 4 levels, what we need is not 1 Boolean variable, but we need 2 Boolean variables. So what we'll do is, instead of using just C, we'll use C and D. So C and D will be the rating. Okay, and then we note that we have 3 ratings. So what we can do is we can choose C equals 0, P equals 0. We'll say that this rating is 0. C equals 0, D equals 1, rating is 1. C equals 1, D equals 0, rating 2. And C equals 1, D equals 1, rating is 3. So this basically covers up all the possible options we have with the rating. Okay, so this is the first step, defining variables for us to use in the logic. The next step is to write quasi-logical statements. So these are statements which we'll write in plain English, and then we can then transcribe them as Boolean expressions. So what we've seen here is, if you go back, so the things highlighted in, or rather underlined in blue, are the ones I'm trying to quantify. So that's what I'll do. Okay, so the investor will invest if, and so here is the first case, call that A. I said that, let's see, mechanical design is good and the sales pitch is rated 3. So let's quantify that. So mechanical design is good. What that means is we have for A should be 1. And you said and sales pitch is 3. So what's 3? 3 is, if you go back, it's C equals 1, D equals 0. Okay. So that's the first statement here, this part. Next one is the mechanical design is good, or the business potential is good, and the sales pitch is rated either 2 or 3. Okay, so let's write that down, and remember that there's an or here. So let's write that down. So this or B, mechanical design is good, business potential is good. Okay. And there's an or, business potential is good, and sales pitch is either 3 or 0 or 2 or 3, I think. So 2 is P equals 0, P equals 1, 3 is, sorry, my bad. C equals 1, D equals 0, and 3 is C equals 1, D equals 1. Okay, so the keywords, remember, this is or, this is or, this is and. Okay, so third step is we'll take these 2 statements and write a Boolean expression. Okay, now here I should also put y equals 1. That's the output. So the way you write it is y equals, and you need to think of how you can, the way to write this is the trick here is to basically write an expression such that you can show that y, the output comes out to be 1. And the way you can get y equals 1 is by trying to write this and in such a way that when you do the product or sum, it'll come out to 1. So what I mean by that is, here we have 1, c equals 1, d equals 0. Is that right? That's not right. This is 3, right? So 3 should be 1. My bad. Now, how can we get y equals 1 with a equals 1, c equals 1, d equals 1? We need to take the product. Okay, so now if a, b, c all are 1, like you have over here, then y would be 1, right? If any of those are 0, then y would be 0, which means that it will satisfy this logic that it's going to be 1. Now there's an or, so I put a plus, and the same thing I do with b. So mechanical design is good, so a equals 1, so I write it as a. Business potential is good, so that's an or. So there's a plus. Since b is 1, I write it as b because a or b both need to be 1 in order for y to be 1. And then there's an and. So, and with another statement, which now should be based on C and D. So again, I try to figure out what can I do with C and D such that the product of these equates to 1. So if I have C equals 1, D equals 0, I need to take C times D complement, because if I do C times D complement, I'll get 1 times 1, which is 1, plus C equals 1, D equals 1, C dot D. This A is A. Is B or B. Okay, so now we have this expression. The next step is clearly we don't want to stick with this complicated expression, so we need to, yeah. Yes. A, B, yes, my bad. This should be, okay, thanks. Okay, so the final step is to simplify the Boolean expression. So let's try to see how we can simplify this. So I'll copy this to the next page and then try to simplify it. So the fourth step . So here I rewrite it A, C, D plus A plus B dot C times D times, just check that. It looks good. Okay, the most immediate thing I think I can do is I can simplify this part. So let's do that. A dot C dot D plus A plus B dot. So I can pull out C. We have D plus B. But D plus D complement is same as 1, right? Because 0 and 1 or 1 and 0 will be 1. So this will be equal to 1. So A dot C dot plus A plus B dot C. Let's see if I can distribute C. A dot C dot D plus A dot C plus B dot C. maybe I can pull out a.c from here. A.c dot d plus 1, because this is 1 here, plus b.c. But if you do d plus 1, right, d can take only zeros and 1. 0 plus 1 is 1, 1 plus 1 is 1. So d plus 1 is simply 1. So we have a.c plus b.c. I think the last step I can do is a plus b.c if needed. I don't think I can simplify further than this. This would be 1 or 2 and this is going to be 1 and 1 and 1 or 1 or. Okay, so the first one requires 2 chips or 2 ICs. This one also requires 2 ICs. Why you need 2 ICs? Because the OR gate OR is available as a chip with 4 OR gates, and the AND chip is available as 4 AND gates. So you require 1 chip each, which is the 2 ICs, and then same for down on. But if you see this expression, this is the same expression I got earlier. Here was the solution I got from my last problem. It was the same expression, exactly the same. So what I can do is I can convert that to, using De Morgan's law, I can convert to this expression, which now has only NAND gates, and that will simplify it from 2 ICs to just 1 IC. So using De Morgan's law, we just put a similar expression is the same as previous example. And so we can write using De Morgan's law, we have y equals a.c dot c. Wait, maybe I got this wrong. Hold on. This doesn't look right to be. Oh, okay. Yeah. So a.c. Okay. Then no, not me. So this should be. I wrote the way I wrote it is incorrect. This should not be. So if it is written this way, remember you need a NOT gate to first invert A and B, but you don't require to do that. So you need, that's not the right expression, it's this. This is actually AND, NAND, right? So three NANDs, which means you need 1 IC. Okay, so that's how you will solve the problem. Now, you could go a step further. If you want to do this in real world, what you do is you'll think of the problem at hand like I did. You'll write this expression, then buy the required chips, you wire it up, and you have something which will work for you in terms of taking the right inputs and providing the right outputs. This can be used, for example, if you want to do home automation and you don't want to use a microcontroller, you can use logic gates, so that depending on the inputs through maybe switches, it will give you the right kind of output.